Hello everybody, this is Caleb, and in this video we are going to go ahead and start writing some Swift code and learning about how it works and all the different things that we can do with it. So we're going to begin with what's called an Xcode Playground, and as you can see here, it's a place where you can explore new ideas quickly and easily in Swift code. So go ahead and click on that button there, and then in the window that pops up, what we're going to do is ensure that iOS is selected for the target. If you were developing for tvOS or macOS, you could select those targets as well. So choose iOS, and for this example, we're going to choose a blank playground. There are other types you can use as well, but for the scope of most of this course, we will be using blank playgrounds and single view applications. So go ahead and choose blank playground, and we can save this as variables and constants, or whatever you want to save it as, and then save it somewhere on your computer that you will remember. And I'm going to go ahead and make this a little bit bigger, and I'm going to pull over this little terminal here, and right at the beginning what we see is a variable. Okay, now you might be wondering, what is a variable? What is a constant? What makes them different? That is a fantastic question. A variable is, at its simplest, a container used in programming to store a value of some type. Now there are plenty of different kinds of information that we can store in a variable, but the most important thing you need to know is that the data stored is variable. That's the point. It can change. It can be modified. So in this example, we are provided with a variable called str, and that stands for string. That is one type of data that we can store. And I'm going to leave a little comment here. Variables and constants can be strings. Okay, and strings is a text data, like so, and it's indicated with quotation marks. Variables and constants can be strings, numbers, Booleans, or collections, meaning a collection of any of these data types, okay? We'll talk about those in a later video. But right now, we have a variable here called str, which stands for string, so I'm actually going to extend that there and just make sure that we know that it is in fact a string. And you might be wondering, well, how does the code compiler here know that this is a string? Well, we use quotation marks, and whenever the Swift compiler sees that, it does something very cool called type inference. And it knows that it is a string data type without you needing to explicitly declare it. Now, you could, by typing var string 2, you could specifically declare it as a string, okay, which is, valid, completely valid. And these are two variables that are basically exactly the same except for the data. One explicitly declares the type, and the other is implicit. It's implied. So we don't need to really think about that too much right now, but let's see how strings work and how we can actually deal with them. We've set the value of this string to say hello playground. But what happens if we want to change what that string says? Well, to do that, we need to type string equals, and then we can set a new value. We can save a new value into this string variable. So I might say, hello student, to you. Now if I run this, you'll see on the right-hand side here, there will be a printout. First, it says hello playground, and then later it says hello student. We have now set the value of that variable. And what I'm about to do is I'm going to call a function, and a function is basically a set of instructions in code that we can write and then replicate and reuse over and over again. We'll talk about that in a later video, but there is a function that anyone developing in Swift has access to called print. And we can pass in any items into this function, for instance, our string variable here, and what it will do is it will print it out down here in what is called the console, all right? So as you can see, hello student printed out because we changed the value. But what do you think would happen if I move this and pasted it before we change that value? Well, let's run it and let's see what happens. We get hello playground. But wait, hello student is right there. This is the cool thing about code. Most of the time, the code that you're going to write in this course is going to operate from top to bottom. So if we declare the variable here, it's almost like we take a stamp in time, a timestamp, and this is at this line 5, this is the value of the string variable, hello playground. If we try to print out that string variable, it's going to print out the last state that was set, going from top to bottom. if we move it back down below hello student and run it again, you'll see that it now prints out hello student. So that is how that works. That's how we set values in variables. It's very cool. But strings or text data, that's not the only data type that we can deal with. We can also deal with a kind of number called an integer. And an integer is a whole number. So there is no decimal after the end of the number. There is no fractional pieces. It's only whole numbers, 0, 1, 2, 3, 4, 5, and so on. And if we wanted to create an integer variable, we could type var bank balance, and we could set it to 1,000. So let's just pretend that we have a random bank account and there are $1,000 in it. You can either type the values like so, or if it's easier for you to identify, you can put commas and they work just the same, but I'm not going to. Now, if I wanted to make this explicitly declared as an integer, and we'll talk about why you might need to do that later on, but all I would have to do is type a colon and declare it int. Okay, and that is an integer in Swift, int, int. But since Swift is super smart, we don't need to do that. We can just go ahead and say var bank balance equals 1,000, and it's going to infer that this value is in fact an integer. Now, what if I wanted to buy some cryptocurrency? So let's say, I wanted to buy some Ethereum. And at the time of this video being recorded, Ethereum is at $290. So I'm going to go ahead and pass in 290. How do we actually deal with these variables? What can we do with them? That's a great question. What I need to do is I need to set my bank balance to be different. If I buy something, right? If I bought an item at the store, my bank balance should decrease if the store is doing their work properly. So what I can do here is I can set my bank balance to be equal to my current bank balance. And you might be thinking, whoa, slow down. Basically, what I'm doing is I'm using the right side of the equal sign here to do all of the math I need, and then I'm going to set that value to my bank balance variable, so it'll update. Now, what I want to do is I want to take my existing bank balance, and I want to subtract the price of 1 Ethereum. Now, when I run this, I want you to look over here to see what prints out. 710. So my bank balance is now set to 710. That's pretty cool. And if I were to actually print my bank balance there, if I were to run it like so, you would see that 710 prints out in the console and on the right side. Very cool stuff. You can use any normal math operators like addition, you can do division, you can do multiplication, but in this case, subtraction obviously makes sense since we are buying 1 Ethereum. And that is how you can work with integers. And believe it or not, working with other types of numbers with decimal points and with fractional bits, it works the same exact way. We can use the same types of operators. However, we'll talk more about this in depth when we get to our numbers video, because there are lots of different types of numbers and you can't always work with them in the same ways. So that is how we work with integer values and how we can actually subtract variables from another and then set the value in the same variable. Really, really cool stuff. Next up, we're going to quickly talk about Booleans, okay? And a Boolean is either true or false. It's called a Boolean because there are 2 options, true or false. And what I can do here is I can set a variable called am I awesome. And for now, I'm going to set it to true. Maybe I, did something really cool or bought a Tesla or did something cool, made myself awesome. And if I want to use this, I can write what is called a conditional. And it's where we can set a certain condition, and if that condition occurs, then we can execute code based on it. Otherwise, we can execute other code. And that's probably a lot of mumbo jumbo at this point, but let me show you how it works. What I can do is I can type if am I awesome, and we're going to check to see if it's true. So if it is true, we can do something else. So let me put a little comment here, do something awesome. But what if that isn't true? What do we do? Well, what I can do is I can say else, which is the code way of saying otherwise. Otherwise, I will do something not awesome. So sad. But check it out. We're getting an error here. It's saying use of equals in a Boolean context. Did you mean double equal sign? And yes, we did. I did that on purpose because I want to show you a very key difference. when you are establishing or setting values, you use the single equivalency sign here to basically say that you are setting a value. This variable is equal to this value. But if we want to check for equivalency, which is a key difference, we need to use two equal signs. And what this does is it checks if a variable is equal to another value. And you can use this for all different kinds of things. I could say, hey, if my bank balance is equal to $700, I could print out something saying, hey, you have $700 left. If I could say, if it is less than or equal to $300, I could print out alert, low balance. I could do all kinds of things, which is really cool. So let me go back in time here, and we're going to change this up. So if am I awesome is true, we're going to print a little message. We're going to say, I am awesome. Okay, that's pretty easy. But what if I am awesome is not true? In that case, we're going to want to print something else, like so. We're going to print, I am not awesome. So sad. And if we run this, at the current moment, we will see I am awesome print out. Boom, right there. Very cool. But what if we wanted to modify this? What if we wanted to set it to false? Well, I could type, am I awesome equals false. And I'm using a single equal sign here so that I can actually set the value. I'm not checking for equivalency. I'm changing the value. So if I run this, you will see I am not awesome prints out. So sad. But there's an even easier way we can do this. And there's something called the logical not symbol. And what it is it is an exclamation mark. If you put the exclamation mark in the front of a Boolean, like so, if am I awesome equals not am I awesome, what it does is it inverts the value. It sets it to the opposite one. So if I comment this out here, or just delete it, you'll see that it goes back to I am awesome because I am awesome is true. But if I set I am awesome to be equal to not am I awesome, it flips the value and we get the opposite. I am not awesome. So that is how that works. But you know what? I'm going to get rid of that because I'm awesome. Anyway, moving on. We have just now talked about 3 separate types of variables, and I'm going to just clean up some space here and make some room for constants down at the bottom. Now, if variables have data that is variable or can change, constants have values that do not change, and they're really good for setting values that should not change. So what I'm going to do here is I'm going to write a little note, constants, and we're going to create a constant here. We're going to go ahead and type let age, and I'll say at this point my age is 16. That's not true. I wish it was, but sadly it is not. What I can do here is I can write a little conditional that is maybe something that would be used at a club or a bar. I could say if age is greater than or equal to 21, with the little curly brackets there, I can type print, and we can print out a message here. Time to drink some fancy drinks. But what if I'm not 21? In this case, my constant is 16. I could type else print head home, kid, you're too young. Head home, kid. And if I run this, you know what's going to happen. It's going to say, hey, head home, you're too young. But what if I, a clever programmer, could hack into the system here and set age to be equal to 21? Haha, they'll never catch me. If I run this, we get a crash. It says, hey, there's an issue. Cannot assign to value. Age is a let constant. That means the age variable cannot be changed, which obviously your age is variable. It does change every year, but on a day-to-day basis, you are pretty much the same age for the entire year. So in this instance, we cannot change the value of this constant because it is, well, constant. This is a very simple concept, but sometimes it gets confused. So make sure that you understand the key difference between a variable is that the value can be changed, whereas a constant, once it is set, it is locked in stone and cannot be modified. There are plenty of other types that we will get to in future videos, but for now, this is how variables and constants work in Swift 4. If you had trouble with this video, you can always go back and watch it at a slower speed or watch it multiple times until you understand. That's what I would recommend, and let's head over to the next video and let's continue learning about Swift types.